I'm Anil Kumar, and here is part 2 of our application question on average rate of change. The question was, sketch position time and velocity time graph from the information given below. The position function of a cheetah moving across level ground in a straight line chasing after prey is given by the equation s of t equals to t cube minus 15t square plus 63t, where t is measured in seconds and s is measured in meters. Its motion along the distance time line is displayed. Well, in part 1, where we discussed this question, we had given that motion along the time. Basically, it was something like this, where the turning points were at t equals to 3. This turning point was at t equals to 3, and the other one was at t equals to 7, with a hitch in between, and there it was t equals to 10. So that was the graph. I kind of omitted here so that I can have more space to work with. Now in this part 2, we will see how to sketch velocity time graph. I'd like you to go through part 1 also so that you understand how we sketch the position time graph. Now we know that s of t is equal to t cube minus 15t square plus 63t. We also know that there are turning points here at t equals to 3 and 7. That means at these turning points, velocity is going to be 0, right? So that is an important information which we get from the sketch. Now we'll find the equation of velocity from displacement equation, and that we can do by finding rate of change, right? Instantaneous rate of change. So that's the key thing to work with now. So to find rate of change, what we should do is we can apply difference quotient method. So velocity at any time will be equal to, we can say, s of t plus h minus s of t divided by t plus h minus t, right? That difference quotient should give us an equation for velocity, and from there we should be in a position to sketch the graph. So let's do this. It really means that t is replaced by t plus h, right? So what we get here is t plus h whole cube minus 15 times t plus h whole square plus 63 times t plus h. So that is the first part, right? Take away s of t, which is t cube minus 15t square plus 63t, right? Divided by t plus h minus t is 1 over h. So we can say everything divided by 1 over h. Everything means, let me put a bracket here. So all this is the numerator and divided by a. So that's how we get our equation. Now we'll expand this equation and simplify. So a plus b whole cube is a cube, it is t cube, plus 3a square b, 3t square h, plus 3th square plus h cube, right? That is t plus h whole cube. Now 15 times minus 15 times t plus h whole square gives me t square plus 2th plus h square, right? And then we have 63 times t plus this. So we can write this as plus 63t plus 63h minus all this, which is okay, let's put them in brackets itself. T cube minus 15t square plus 63t. Now all this is in brackets, and we are dividing all this by h. So we say 1 over h here, okay, equals to what? Let's simplify. We know these three terms will cancel out. So let's see, t cube will go with this t cube minus 15t square. So that means 15 times t square. 63t is a constant. take away that from 63t, right? So that is 63t. Okay, so we have now left with the balanced terms which we can club together. Now you will observe that we have h in all the remaining terms. Is that okay? So we have 1, 2, 3, 4, 5 and 6 terms. So let's write them down. So 3t square h. So we have 1 over h times 3t square h plus 3t h square plus h cube minus 2 times 15 is 30 th minus 15h square, and then we have plus 63 plus 63h. Now from this expression, if we cancel out h, right, and rearrange these numbers, so what we have here is, we should know that h is a very, very small quantity, small change in time. So what we know here is that h is very, very small as compared to 1, right? So in the first step, what we will do is, we'll cancel out, we'll factor h and then cancel this out. So what we are left with is h over h. We are factoring h out, so we get 3t square plus 3th, and here we get plus h square minus 30th minus 30t, because we factored out h from here, and we have minus 15h, and then we have plus 63. So that is what we get. Now h and h cancels. Since h is a very small quantity, we'll neglect the terms which still have h in them, right? So we are left with the other terms, which are 3t square. So approximately the rate of change of displacement, that is velocity, is equal to 3t square. Now these are the terms with h, so we are cancelling them out, minus 30t plus 63. So we neglected the terms which have h, since h is very small, right? So we neglected these terms. Now from here, we can actually take 3 common, and we get t square minus 10t plus 21, and we can factor this 3 times product of 21 and sum of minus 10. So that gives us t minus 7 times t minus 3. Now this clearly explains the turning points. So this function v of t equals to 3 times t minus 7 times t minus 3 indicates if t is 7 or if t is 3, velocity is 0, right? So we have a parabola here which can be drawn very accurately with the help of this given equation. Now since we have run out of space, what I will do is I'll kind of sketch it on one corner, right? Okay, so let me just sketch it here. So it is a parabola which will be something like this. Correct? Now here we can calculate the values. We know these times, here we have velocity v of t, here we have time t, t is in seconds, velocity is in meters per second, this is 0 for us, right? Now this point is t equals to 3, this point is t equals to 7. The minimum value should be in between 3 and 7, right? So we can calculate that minimum value. So 7 plus 3 is 10, and in between is 5. So if I write 5 here, I can calculate this value. So we can write v of 5 as equal to 3 times 5 minus 7 times 5 minus 3, which is equals to, this is minus 2 times 2 minus 4, 4 times 3 is minus 12. So this value is minus 12 for us, correct? So that's the minimum value. Now, which is at 5, t equals to 5, correct? When t is 0, what is the value? Which is the starting point? We can calculate that also. v of 0 is equals to 3 times minus 7 times minus 3, right? That gives us a value of 63. So this value is 63 meters per second for us, correct? Likewise, we can calculate some other values and get a very accurate graph, which will be velocity and time function. I hope in short you understand the concept, right? And this figure given to us right in the very beginning helps us to sketch the graph, correct? I am Anil Kumar and I hope you like the approach and this video. Thank you and all the best.